Hello, everybody. My name is Clark Fancher, and I am the product manager for the Optimization and Licensing Assessment, or OLA, at AWS. Thank you so much for investing your time in this webinar as we explore OLAs as a way to answer questions like, how do Windows workloads fit into a broader migration strategy? And how do I optimally use existing licensing entitlements to plan for a cloud future? We hear these questions from customers all the time, and a recent report out from Flexera reflects that, stating 56% of organizations report that understanding cost implications of software licenses is a challenge for software in the cloud. So know that you are not alone if you have these questions as well. Right. So the main takeaways from this webinar are to understand what common challenges customers see with Windows workloads, how those are addressed by running an OLA, and also being able to articulate why this is important. By the time you are done today, you'll understand what the OLA is, including the process and what you get out of it. And finally, we will touch on how you can lead your organization to actually get started with an OLA. So the content of this webinar will lay some context to help you understand the most important considerations when migrating Windows workloads, regardless of your experience with Windows workloads, Windows licensing, or even AWS. We have a diverse set of experiences and titles and job responsibilities on the webinar today, and this 100-level webinar is going to be for everybody. So first, we will briefly discuss why and how organizations run Windows workloads on AWS before moving to the unique licensing implications of those Windows workloads in AWS. We will then touch on why this topic is important and impactful to your organization's IT strategy. And then we will introduce the optimization and licensing assessment as a framework to tie all of these common Windows workloads challenges and solutions together. And we'll close with that call to action to help you guide your organization. So first, just let me briefly touch on some of the common business problems leading customers to run their Windows workloads on AWS. We have the best global infrastructure for running workloads that require high availability, which is a common challenge, right? So we have 76 availability zones across 24 regions. This is one of the reasons why the next largest cloud provider had 7 times more downtime hours than AWS in 2018. Also, as I mentioned earlier, lots of organizations are wondering about the features, services, and tooling available to support them once these workloads are in the cloud. These are great opportunities to explore AWS License Manager so you can create custom licensing rules and set guide rails to ensure compliance when you bring those licenses over. Or, for example, Amazon FSx for Windows File Server to simplify your Microsoft SQL Server high availability experience. So when I'm talking to customers and I hear that Windows licensing and compliance sound daunting, it's easy to work backwards from these common challenges to find AWS offerings that solve them, as we will see with the Optimization Licensing Assessment, or OLA. I like to summarize the why Windows on AWS by looking at a quote from Red Cat saying, if you are running Windows workloads with other workloads or are thinking about future integrations with advanced analytics or machine learning, you would be crazy not to consider AWS. And that quote mirrors the sentiment of many other Windows customer references and customers that I talk to day in and day out. Organizations choose to run Windows workloads on AWS for a whole host of reasons. So let's transition into the effects of Windows licensing on AWS to see what this means for your business. Businesses license Windows workloads in the cloud just as they are obligated to license on premises. And there are a couple of terms I want to first define before we jump into the implications of licensing these Windows workloads on AWS. The first term is software assurance. This is purchased from Microsoft, often as a part of an enterprise agreement, and it comes with a number of benefits, including license mobility, which brings me to the second term, license mobility. It's a Microsoft software assurance benefit that allows you to bring specific product licenses to shared cloud infrastructure, including default shared tenant, Amazon EC2. If you don't know what that means yet, don't worry, we're going to talk on that later in the session. Active software assurance is required to be eligible for license mobility. This is not a licensing deep dive webinar by any means. So just for additional information on license mobility, do check out the license mobility page on the AWS site. And also just know that every product has an individual software assurance section that indicates license mobility eligibility. So make sure to reference these product terms for your personal edification, as well as to ensure that you are always maintaining compliance. The license mobility eligible product that is most relevant for OLA is SQL Server. We'll call this ACT BYOL, or Bring Your Own License. As the name suggests, it's the process of bringing previously purchased on-premises licenses to AWS. And when you BYOL, the licensing cost of the product you bring is no longer included in the price of the instance on AWS. And just quick caveat, when you bring licenses, you are also responsible for managing your licenses from a compliance perspective. And Amazon EC2 has features such as AWS License Manager and targeted placement on dedicated hosts, which help you maintain license compliance throughout the lifecycle of your licenses. And in addition to bringing your own licenses, or BYOL, you can also purchase licenses from AWS where you no longer need to make an upfront commitment. AWS handles the compliance, etc. So you can BYOL, and you can also purchase new licenses included from AWS. So, what are the effects of being able to bring licenses or buy these licenses from AWS? Whereas with a homegrown application without third-party licensing requirements, you might select a compute option in AWS based specifically on tech spec requirements of the workload and just throw it in default tenant EC2. With Windows Workloads, the licensing also plays a determining role in how you deploy that workload on AWS from a compliance perspective. So different products have different licensing models, but the two products that optimization and licensing assessments focus on, Windows Server and SQL Server, are licensed by the core. So there are direct cost implications associated with the type of AWS instance you pick, because you want to be compliant with Microsoft's product terms and you want to minimize the cost by only licensing what you need. Which brings me to my next key takeaway. The licenses you own will impact what and how you deploy on AWS. It's just a fact. So now let's talk about why this matters. Understanding the importance of matching licensing purchases to licensing needs requires understanding the relative price of licenses versus the underlying compute. SQL Server licenses might be one of the most expensive software licenses your organization buys. And let's take a look at some examples that show the pricing of various instances with and without SQL licensing, so you can get a sense of the cost impact here. If you'd like, head to the AWS cost calculator, go through this exercise on your own, get the most up-to-date and specific pricing for your region, but the same principle is still going to apply. So modeling out the on-demand cost of one C5 extra large Amazon EC2 instance in US East broke down to the following scenarios. Windows Server plus SQL Server Enterprise at $13.57 a month, Windows Server plus SQL Server Standard at $610 per month, and Windows Server only at $259 per month. So from this, you can see how every SQL core license that you can bring over has a major impact on TCO for the migration. We're talking about an over $1,000 delta with just Windows Server versus Windows Server plus SQL Server Enterprise license included from AWS. I was just talking with a customer the other day who had gone through this process and identified over $1 million in savings on SQL alone through compute and licensing optimizations across just under 700 servers. So this leads me to my next takeaway. Licensing costs are a significant part of a cloud total cost of ownership analysis. So I also just quickly want to touch on the effects of AWS on Windows licensing. So just as Windows licensing affects what you do on AWS, your AWS strategy will affect how you license Windows products moving forward as well. There's some specific implications you need to understand here. The enterprise agreement your organization has will dictate your licensing strategy in the short term, but reducing your licensing requirements by either, say, downgrading the additions that you're purchasing if you're not using all of the features in, say, SQL Enterprise, as well as reducing the numbers of cores that the workloads require to run, will collectively save your organization money during your next renewal cycle. And also, regardless of your renewal cycle, is going to save you money versus buying all new licenses from AWS. So, after going through this, you understand some of the factors at play in licensing and the magnitude of the software costs. Let's talk about how this looks in AWS. So the main service to run Windows workloads on AWS that we're going to discuss centers around Amazon Elastic Compute Cloud, or Amazon EC2. It's a web service that provides secure, resizable compute capacity in the cloud. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. Within the family of EC2 offerings, there are different deployment options that are compliant with different BYOL Windows workload scenarios. We're going to explore some of these now so you can start to visualize how licensing can concretely determine cloud deployment. So this first case study here, looking at EC2 shared tenancy, SQL Server with license mobility benefits, right? So shared tenancy Amazon EC2 instances are probably what come to mind when you think of cloud computing. They are multi-tenant servers hosted for the use of multiple customers, where AWS determines which host instances run on. You pay per instance, right? And an example of something that you might run under shared tenancy would be SQL Server 2012 with license mobility. SQL Server licenses with active software assurance are eligible for license mobility and can be deployed on default, as you see here, or even dedicated tenant EC2. So Amazon EC2 offers two purchasing options that provide you with dedicated infrastructure. Those are dedicated hosts and dedicated instances. It's important to note that most BYOL scenarios are supported through the use of dedicated hosts, while only certain scenarios are supported by dedicated instances. So just keep that in mind over the next couple of examples here. The next view, a dedicated host. So a dedicated host is a physical EC2 server fully dedicated to you. Amazon EC2 dedicated hosts allow you to use your eligible software licenses from vendors, including Microsoft, on Amazon EC2 so that you get the flexibility and cost effectiveness of using your own licenses, but with the resiliency, simplicity, and elasticity of AWS. With dedicated hosts, you have an option to control instance placement and gain visibility into the number of sockets and cores installed on a host. And you can use these features to bring your own software licenses bound to virtual instances, sockets, or cores, including, again, relevant for today's conversation, Windows Server or SQL Server. Dedicated hosts are often used when customers bring licenses that do not have software assurance or license mobility benefits. Which brings me to the last example, dedicated instances. Dedicated instances are single tenant servers hosting instances dedicated to one AWS account. AWS determines which host instances run on, and you pay per instance and hourly fees per region. Just a quick side note, again, this is not a licensing deep dive, but Microsoft Developer Network or MSDN subscriptions purchased prior to October 1st, 2019 are eligible for deployment on EC2 dedicated hosts or dedicated instances. Microsoft has made changes to the license terms for MSDN subscriptions purchased or renewed after October 1st, and these new terms are effective at subscription renewal. Again, the purpose of this talk is not to be a comprehensive view of licensing, so do refer to those resources on the AWS site that we'll be sending out after the webinar. So how does the OLA or optimization and licensing assessment tie all of this together? We've talked about the most important considerations when deploying Windows workloads on AWS, and you might agree that it is a lot of information to consume. When it comes time to apply this knowledge, AWS has a framework that will help your organization streamline the 3 steps of information gathering, analysis, and planning required to apply these concepts to your Windows workloads and your cloud migration strategy. That framework is called the Optimization Licensing Assessment. So before jumping into the first step of how it works, I want to work backwards a bit and examine an output from the OLA, which is something that you can expect as a customer if you go through this process. The next 2 slides show 2 key views from an OLA output that together highlight the significance of the BYOL motion, in this case, BYOL SQL Server. This is the kind of output that you can expect as the outcome of your organization's OLA. This example specifically looks at 1,220 OS instances comprised of 1,123 virtualized servers and 97 bare metal servers. The data was collected using TSO Logic's agentless collector from June 15th to June 26th. And the first slide models the cost scenario where the customer does not BYOL anything. This comes out to a total of $2.9 million annually. The second view shows the same customer scenario using the same underlying data to model the BYOL SQL Server scenario. If you are an especially keen observer, you might have noticed that for this customer example, the core count required was reduced by 80 cores. We will get to why this is the case in a bit, but know that the first part of the OLA output is the summarized core count requirement to run these workloads on AWS. And the second part is the comprehensive list of instance recommendations in AWS, which power the cost model summary seen in these slides. This is where you can see the instances and cost breakdowns depending on whether you chose to model all on demand or a combination of upfront and on demand with options like reserved instances, for example. Instance recommendations and core count requirements are the foundational components of an optimization and licensing assessment. Now let's talk about how we get there. The OLA is comprised of 3 steps: data collection, data analysis, and planning. The names are fairly self-explanatory, but collecting data gives you the baseline to make recommendations from. Data analysis is where the tooling makes automated recommendations so you know what to deploy on AWS, and the planning phase is where you take this information and plan your next steps for migration. Step 1, collection. So regardless of whether your organization has 10 servers or 10,000 servers, you can now understand why you want a complete inventory of your hardware and software usage when considering a migration, because this inventory data will shape where these workloads live in AWS. Using your choice of first-party or third-party tooling, you can automatically discover everything in your environment, right? And the different tooling collects data using different methods across different protocols, but from a collection perspective, the main takeaway is that there are both agent-based and agentless approaches to getting the data needed for OLA. Data collection ideally runs for about 4 weeks to catch those monthly processes that skew resource utilization patterns. And perhaps you're saying to yourself, deploying this kind of data collection tooling is not an option for my organization, and that's okay. The AWS Migration Evaluator, formerly TSO Logic, is able to ingest a flat file static data set that you provide, including the utilization data for your workloads. So this is some sample data just to help you understand what powers the calculations and the granularity of the data needed should you go this flat file route instead of using one of the collectors that are part of the OLA framework. So step 2, analyze. Now we are getting into the O part of the OLA, which stands for optimization. So going back to that thought experiment, in the absence of tooling or data about the workloads that you have running on premises, how would you conceptualize a migration to AWS? You might look at the specifications of your on-prem hardware and look at the specs of instances offered by AWS and find what looks like the closest fit. While this is a legitimate strategy, what it's missing is where tooling-driven approaches like the optimization and licensing assessment really shine by incorporating application utilization data. Rather than manually assigning instance recommendations, the tooling will do this for you so you know what to deploy in AWS. The software will look at actual resource consumption of the underlying workloads you have on premises, including RAM and CPU utilization, and determine the right instance to drive the performance you need without incurring unnecessary compute costs from a more expensive instance family, for example. And as we mentioned previously, these softwares are licensed by the core often, and the tooling goes a step beyond just recommending the right instances and also provides a count of the minimum required cores to license the workload while still maintaining the performance that you demand. So to say it another way, the tooling allows you to take advantage of AWS's optimized CPU feature where you can reduce the number of cores utilized by the instance. In addition to the instance recommendation, the tooling allows you to work backwards from the Microsoft software compliance requirements of your workloads to model those different hosting scenarios like dedicated hosts, for example. Another benefit from the tooling is the ability to model out different cost scenarios for on-demand or reserved instances for cost savings. And then finally, step 3, plan. The final step is what drives action for your organization. A list of recommended instances, including summary stats on cores reduced. Again, the outcome of an OLA is an output like we saw in the previous slides that summarize all of this information. And depending on the needs of your organization, this is where you can take your cost models and present them to the executive team, or even start planning your migration by building out move groups and starting a proof of concept. Before jumping into the demo, I want to share a customer anecdote that is really the holy grail of these types of optimizations. The customer started with an initial lift and shift 3-year reserved instance cost model of just over $2.5 million. The OLA right-sized the instances based on resource utilization, getting that cost model to down under $1 million. And then the dedicated host modeling brought the total 3-year commit down to just $540K. Part of this cost reduction was leveraging the optimized CPU analysis, which reduced the SQL core requirements from just over 500 licenses to around 370 required. And while your optimization outcome will depend on what you have currently deployed as well as your entitlements, we do see numbers like this from customers all the time. Okay, so now we're going to walk through some of the underpinnings of an OLA to help you better understand how we actually apply this framework in the real world. In this case, the OLA is powered by the AWS Migration Evaluator, formerly TSO Logic. For this OLA, we have 3 teams involved in the engagement. There's the customer team, the AWS OLA team, and the TSO Logic Solution Architecture team, all with different responsibilities to ensure success of the project. So first, the customer met with the optimization and licensing assessment team to figure out the licensing parameters like what licensing entitlements do I have today and what assumptions can I make around BYOL? And other elements like how should we handle zombie servers identified? If they don't have utilization, should we think of them as being those passive failover nodes, or could they be true zombies like a template server in vCenter? During the initial conversations between the customer and the OLA team, the customer also determined that they have software assurance on all of their SQL licenses and will be considering SQL BYOL scenarios for the cost models. Then, after assessing the quality of their inventory data, the customer decided to use TSO tooling to collect the data. So everything you see on the screen here is based on that collected data. Through the TSO logic collector, they also used TSQL to pull the software / addition information in addition to the standard CPU and RAM utilization metrics. Now, this screen is the visualization of all of that ingested data. Here we are looking at the entire environmental breakdown, but if we wanted to, we could also go over to the operating system section and just look at the Windows portion of the environment, right? The portion that's going to be driving the licensing specific cost optimizations. Now, let's build the cost model for our BYOL SQL scenario. So we're going to go over to the environment. We're going to look at the whole environment, and then we're going to start building out that scenario. So when you go through this process with TSO, a solutions architect from the TSO team will work with you on modeling your scenarios via the viewer that we see here. So first, we'll go ahead and select AWS, and then you'll see that you can select the region that you want to deploy in, that you can select the purchasing type that aligns with the organization. And obviously you can build out multiple models here, but for the sake of this example, we will go with all upfront 3-year standard reserved instances. But again, you could go with on demand if you're not interested in making any upfront commitments. We'll name it 3-year RI SQL BYOL. This is where, based on the conversation that you have, you can determine whether you want to include zombies in the modeling, right? So if there is no utilization, are they relevant or not relevant for the conversation? For this example, I will exclude them. This is where you can specify the BYOL parameters. So you can either leave the core price at the default of 0, or if you want a more aggressive core reduction, you can put in your true per core licensing price here. And in addition to getting slightly more aggressive with the recommendations, if you put in your per core price, then you will actually get more of a true budgetary number where you have that EC2 and EBS spend as well as accounting for existing SQL costs, right? And based on the conversation that the customer had with the OLA team, they know that they have license mobility via software assurance through their EA on all of their SQL licenses, so we'll check this box. And then finally, under right-size compute provisioning, the customer doesn't want to consider burstable instances, those T-type instances, so we'll just uncheck this box. And then from a scaling perspective, the customer recognizes that during their collection period, that 2-4 week period where they use the TSO logic tooling to pull in the utilization data from their environment, they notice that this is probably not going to be a period of time that is representative of their true business utilization, so they want to bake in a little bit of headroom here. So we'll move this slider up to 125% to give them that headroom on the optimizations. And then the customer selects peak utilization for the optimizations. This is based on 95th percentile utilization metrics. So that's building out our first cost model. Now let's take a look. So on the left-hand side, as we did before, we have the direct match, or the lift and shift scenario, and this is coming in at $2.5 million. And on the right-hand side, we have the cost models based on compute and licensing optimizations. So let's take a look at this breakdown. 904 VMs were matched to compute instances, and 337 were not brought over because the utilization patterns identified them as zombie machines. The other key piece that we have here is the licensing. Whereas with the lift and shift, we needed 598 cores of BYOL SQL Enterprise, we now just need 340 cores. And previously, we needed 260 cores of BYOL SQL Standard, and now we need just 192 cores of SQL Standard. And finally, you might be a little curious or wondering why we see more cores disabled on the lift and shift scenario versus the right size scenario. And that's because these numbers here have the utilization-based optimizations baked into those instance recommendations. So we actually have an initial reduction of cores, and then this count here is that further reduction of cores after the initial round of optimizations. So this is the level of detail that you get from going through this OLA process, collecting your own data using the TSO Logic tooling. If you want to get a sense of, in addition to the cost models, what other additional data do I get from this exercise, we can just take a quick look in here. This is just a subset of some of the information that you can get at a server level that you can export. If you want to get all of the data that you have at the server level, including utilization of RAM, of CPU, of the AWS instance recommendations, of numbers of cores that are going to be licensed, etc., you can also export that through here. So this is the level of detail that you get. This is what will help you then move on to next steps, like working with cloud economics to build out multi-year migration cost models, or determine your eligibility for other programs within AWS, or even scoping down your environment further for a more targeted conversation around end of support workloads. So how do I get started? Next steps, call to action, compile existing environmental data, especially for your Windows workloads. Understand the granularity of your data to make it easier to determine whether additional data collection will be necessary to drive the best migration outcomes for your business. And then next, this webinar will be hosted on demand, so you can share the link of this webinar with other stakeholders in the organization who didn't have a chance to join the webinar live. And then complete the Contact Us form, which we will provide as a follow-up to express your interest in going through an optimization and licensing assessment, where members of the Windows team at AWS will get in touch with you and talk you through the process. Again, it showed it on another slide. There is no obligation, there's no direct cost associated with going through the OLA process. From there, work with us to create your optimization and licensing assessment output to gain clarity into your optimal Windows strategy and really start to become a thought leader in your organization around best practices for Windows workloads on AWS. And finally, if you have any questions, please reach out to the AWS-OLA@Amazon.com alias. We really want you to be successful, and we are happy to help you along your journey to AWS. Again, thank you so much for joining the webinar. If you have any questions, this is going to be a great time to ask them.